non-organ directed toxicity. So in this topic, we will tackle toxicity that does not affect any organ, but rather affects the cells, genes, and developing fetus. So in our discussion, it will be divided into three categories: neurogenesis, genetic toxicology, and then developmental toxicology. Now, cancer is a disease of cellular mutation, proliferation, and aberrant cell growth resulting to malignant neoplasm. So, this disease ranks as one of the leading causes of death in the whole wild world, and it estimates, I think that would be 70 to 90% of actually human cancers that have linkage to it's either environmental, dietary, or behavioral factors. So I think that percentage in the ranking didn't change yet up until this very own year of ours. So since then, no, it's one of the leading diseases in the whole wild world. So by the way, before we go into deeper discussion on understanding the cellular and molecular aspects of cancer process, now let me tell you or let me show you some of the terms that we will be having, and also I will also let you know some of the pathology and scientific again terms that will be involved in defining the cancer or this disease or toxicity. So here you go. So first off with, when we say neoplasia, this is often defined as new growth or autonomous growth of tissues. Now, to which the resulting growth, or also known as neoplastic lesion, is referred to as a neoplasm. So again, this is the resulting neoplastic lesion, what we call the neoplasm. And by the way, there are two kinds of neoplasm. So we have there the benign neoplasm and the malignant neoplasm. And I guess this is not new words to you guys, diba? So for benign, these are lesions characterized by expansive growth, frequently exhibiting slow rates of proliferation that do not invade surrounding tissue or other organs. So of course, in contrast to that is the malignant neoplasm. So for the malignant neoplasm, it demonstrates invasive growth characteristics which are capable of spreading throughout the organ of origin. And through metastasis, it spreads to other tissues and organs. So again, can someone of you summarize on your own understanding what is the difference between the benign neoplasm and the malignant neoplasm? Based on the definition given, how do you differentiate the two neoplasms? Any of you? Okay, go ahead.
It is a basic knowledge, ma'am, that when we say benign, it is a non-cancerous type of neoplasm, while malignant is the cancerous type of neoplasm.
Okay, yeah. So in layman's term, that is how we perceive the two categories of the neoplasm. Okay, thank you very much for that, Ray. But again, let me just reiterate it. Once you say benign, the characteristic growth of it is expansive, while on the other hand, the malignant is the invasive one. Okay. However, going to the benign again, it doesn't grow that fast, so it has a slow rate of proliferation. It doesn't grow rapidly. Okay. However, the malignant is the opposite one. So it grows massively, it proliferates um, faster. So there you go. So these are the terms that are really quite going to be mentioned from the term cancer. So in classifying neoplasms, the nomenclature reflects both the tissue or cell of origin, and of course, the characteristics of the type of tissue is involved in this. Okay. So when we say neoplasm nomenclature, as I've mentioned, the tissue of origin is also involved. So once you have or you had the result for benign, it has a different outcome towards the malignant. So as what mentioned earlier by Ray, usually in layman's term, if you will hear the word benign, it's usually the non-cancerous type, and on the other hand, the malignant is a cancerous one. So in here, I want you to take note of this so that you will be familiar with the rest of the tissue of origin and the terms of the results of coming from the benign and coming from the malignant. So in this case, the nomenclature reflects both the tissue of cell origin and the characteristics of the type of tissue involved. Now, if you can or if you are observant, most of the benign neoplasm, it has a suffix called oma. Hindi na siya tong oma. It's not a mom in Korean, but oma because it ends with the three letters OMA. Now, mayon mo, Ma'am, same ramang gyapon siya sa malignant. Naman siya OMA. Okay, let me tell you this. Now, for benign, let's say for example, fibrous under the connective tissue. Fibrous neoplasm would be termed fibroma. And let's say, for example, under your benign glandular epithelium, it is termed as adenoma. So, however, under your malignant neoplasm, it can be, it has two categories in it. You have there your carcinoma and sarcoma. Compared to your benign, it is not categorized under sarcoma or carcinoma, but for you, in order for you to distinguish if it is a benign, it only ends with the suffix OMA. So for your malignant neoplasm, it is categorized into two. So from epithelial origin, these are called carcinomas. However, those that are derived from mesenchymal origin, that comes from your connective tissues, blood cells through your muscle. So in specific categories, we have there the bone under your mesenchymal, that is going to be your bone, soft tissues, there you go, and then your, which includes your muscle, fat, blood vessels, and lymph vessels as well, and some of the fibrous tissues. These are referred to sarcoma. So again, there are two categories. Your carcinoma is for those epithelial origin, and then your sarcoma is coming from your mesenchymal origin. That comes from your bones, soft tissues, which includes muscle, fat, blood vessels, lymph vessels, and fibrous tissues. So ay mo ka, kuha na, ayaw mo og kalibog. Again, for your benign, it doesn't require the category of sarcoma or carcinoma, but just for you to be able to familiar it right away, it ends with OMA. However, for your malignant neoplasm, you have the categories between sarcoma and carcinoma. So I know that you are quite familiar with the two categories of malignant. So can you let me know when you hear the word carcinoma and sarcoma, what comes into your mind? What could be the difference of the two? Is there any of you knows about that? Okay, so in summarize, and in addition to your knowledge, carcinomas develop again in the epithelial cells. Mura gini nadumduman. If it is carcinoma, it develops in the epithelial cell. However, when you say sarcomas, it forms in the mesenchymal cells. Again, as I've mentioned, it involves into your bone, soft tissues, including muscle, fat, blood vessels. So it doesn't interchange. It has its own categories. It has its own characteristics. Okay? And tissue of origin. Now back to terminologies. The next term under here is the word, also a most common word to everyone, the metastasis. Now, metastasis is a secondary growth derived from the cells of the primary malignant neoplasm. The term tumor, on the other hand, it describes a lesion that may not be neoplastic, and it is characterized by swelling or an increase in size. So tumor is growing. So scientifically, tumor is not equivalent to cancer immediately. So sige daw, beforehand, when you say tumor, makadungog ba mo, hala na siya tumor, na siya cancer. E nga na ba kasagaran nakadunggan sa tanan? And some, yes, go ahead. Pag
Partly no, ma'am.
okay. Ideally, dili should siya directly term as cancer. So why? So what I mean is that tumor is not the ultimate variable or presentation of cancer. It doesn't mean na pag may tumor ang isa ka pasyente or tao, it means cancer na dayon. But for those who doesn't really know, pag makanog nagali sila og tumor, first thing comes into their mind, ala na siya kanang cancer. So actually no. A tumor must be neoplastic and malignant first to be considered as a cancer. So what is a neoplastic again? Can someone reiterate here what is neoplastic? It was mentioned earlier. What is neoplastic, guys? Or in term of neoplasia or neoplasm.
Of tissue, ma'am.
And Zatare, what was that?
Abnormal growth of tissues.
Okay, yes. So when you also say cancer, it describes the subset of neoplasia that represents malignant neoplasms. So kuha ba? So once a tumor is considered to be cancer, it must be both a neoplastic and a malignant, okay, for it to be considered as cancer. So it doesn't mean that a person has a tumor and the result directly na nato siya maingon nga cancer. It needs thorough specification, and it needs to be identified if it is neoplastic and malignant in order for it to be considered as a cancer. So next is carcinogens. Now there are this could be either physical or chemical agents that causes or induces neoplasia. Again, it must be a new growth, okay? That is which is triggered by either physical or chemical agents. Now, carcinoma or carcinogens can be either of the five categories that we should consider. It could be chemical, viruses, radiation, hormones, or solid materials. So that are the five factors that we can consider in having carcinogens. Now, under carcinogens, there are two types of categories. So, kato siya ang kaning chemical, viruses, radiation, hormones, or solid materials. This can be divided into two. These are called genotoxic and non-genotoxic. So, what are the difference of these two? Those that interact physically with DNA to damage or change its structure, then this goes to the genotoxic. And those that change how DNA expresses information without modifying or probably directly damaging its structure or may create a situation in a cell or tissue that makes it more susceptible to DNA damage from other sources, then these are under the category of non-genotoxic. So in summary, genotoxics are those that interacts with DNA resulting in mutation. So this could lead directly to DNA damage. However, the non-genotoxic, these are modified gene expression but do not damage DNA directly. So naapay mga consideration ay siya mo lead to DNA damages. None unlike the genotoxic, it leads to probably it will lead directly to DNA damage. So that is So that is how it goes. Now, some of the common features of the genotoxic and non-genotoxic carcinogens will be shown on the next slide. So there you go. So these are the common factors or features under the genotoxic carcinogens. This includes the mutagenic, and which can be complete carcinogens. The tumorigenicity is highly dose responsive, and the no theoretical threshold. On the other hand, we have here the non-genotoxic carcinogens. Of course, it is the opposite of the genotoxic. But it includes, on the other hand, again, species, strain, tissues that could specify or the other sources that would lead to possible DNA damage. But again, it is not directly damaging the DNA. So napa siya magamit ng mga species, strain, specific tissues that can lead to. However, genotoxic is leading directly to DNA damage. So that is the difference between your genotoxic and non-genotoxic carcinogens. Now let us see how is the productivity of this carcinogenesis go. So in here, as you can see on the screen, so it comes first with initiation, secondly, it goes to promotion, and lastly, it goes to progression. Now, carcinogenesis process involves this kind of series, okay? Operationally, these stages have been going through all along. Musugod yun siya sa initiation, secondly, promotion, and the final stage is the progression. So let us individually see the process of this multi-stage carcinogenesis. So again, as I've mentioned, the first thing that comes first is the initiation. It is a process that is defined as a stable, heritable change, and this stage is a rapid but irreversible process that results in a carcinogen-induced mutational event. The chemical and physical agents that functions at this stage are referred as your initiators or also known as your initiating agents. Your initiating agents lead to genetic changes, which includes mutations and deletions by which chemical carcinogens covalently bind to DNA to form adducts, or they binding the rest of the covalently bondings. Now, under this one, it has chemical classified um, examples as this serves as your initiating agents. This includes your polycyclic hydrocarbons, your nitroamines, biological agents, and physical agents. Now, by the way, these biological agents could also known be like your viruses, your bacteria, so on and so forth. However, the physical agents, these are referred as your imagings, such as your X-rays and UV lights. Okay, so these are some of the factors. Now, most chemical initiators or initiating agents are indirect acting genotoxic compounds, meaning there is a direct DNA or immediately affect the DNA that goes to damaging. You know what? Before anything else, this requires metabolic activation in the target cell to produce the DNA damaging event. In the simpler term of the scenario of initiation, for an indirect acting genotoxic compounds to produce DNA damage, the chemical must be taken into the target site and metabolized. So same goes along with some of your drugs. Of course, it still needs the active site or the target site nga makaabot sila dito, and then it gets metabolized before it produces its effect, or how does it work. So again, it must still go to the target site and then metabolize. Then the ultimate form of the carcinogen is then able to bind to the nuclear DNA. Now, again, this will result in adduct formation or bindings. An award scholarship committee. Now, aside from that, the initiating event becomes fixed when the DNA adducts or other damage to DNA are not correctly repaired. Aside from that, it also incompletely repaired prior to DNA synthesis. Of course, if there are possible fixation that is happening, there are probable outcome or result of the specific initiated cells. Now, these are the following outcomes. So you have in there, before I got to proceed with the outcome, take note that the initiation by itself does not appear to be sufficient for neoplastic formation. So once initiated cells are formed, their fate has multiple potential outcomes. And these are the following outcomes. The initiated cell can remain in a static, non-dividing state through influences by growth control via either normal surrounding cells or through probably endocrine influence. On the other hand, so you have in there the initiated cell may possess mutation incompatible with the viability or normal function and be deleted through apoptotic mechanism. So or cell death. So lastly, the cell through stimuli such as intrinsic factors or even from chemical exposure, they may undergo cell division resulting in the growth or in the proliferation of the initiated cell. So mas paspas siya, mas rapid siya. Now, if we have the initiation stage, we now have the promotion stage. So, mura ra siya, kung paminawon nimo mura siya frat, no? But here in multi-stage carcinogenesis, this is how it goes. Now, deriving from either endogenous or exogenous stimuli of cell growth, promotion is not the middle nga stage, but it is also known as the second stage of the carcinogenesis process, which involves selective clonal expansion, of which man of the initiated cells to produce a pre-neoplastic lesion. Now, unlike the initiation stage, promotion stage is a reversible phenomenon whereby upon removal of the promoting agent, the focal cells may return to single initiated cell threshold. So sa initiation, it is irreversible. However, in the stage of promotion, it has its own uniqueness. It could be reversible. Now, both exogenous and endogenous agents that function at this stage are referred to as tumor promoter. So, under your initiation, the chemical and the physical agents are known as your initiator. However, under promotion, it is called as your tumor promoters. Tumor promoters are not mutagenic and generally are not able to induce tumors by themselves. Rather, they act through several mechanisms involving the gene expression that changes the result in sustained cell proliferation, either through increase in cell proliferation or it inhibits it. So, or it inhibits the apoptosis or the cell death. Now, the growth of preneoplastic lesions requires repeated applications in order for it to continue the exposure to tumor promoting compounds. Now, while initial exposure to tumor promoters may result in an increased cell proliferation, so mas aggressive na siya. Or it could be under the DNA synthesis in all tissues of the organ. Now, this is usually a transient effect and with repeated applications of the tumor promoter. Only the initiated cells continue to clonally expand and divide. Now, these tumor promoters in general show organ-specific effects. So, naa siya specification. Let's say, for example, we have a tumor promoter of the liver. Para lagi na siya sa liver. Let's say, for example, ang phenobarbital, it is recognized to be a tumor promoter sa liver. Then, it is only for the liver. It could not function as a tumor promoter in the skin or other tissues. Did you get it? So if a specific agent is, let's say for example, specified already to one organ, then it is only specified to that organ. So it only is a tumor promoter of that specific organ. It doesn't allow na pwede pa siya on the other tissues or other areas. So again, let's say for example, if the phenobarbital is for the tumor promoter of the liver, it cannot function as tumor promoter of the skin or the other organs or other tissues. So I hope you get it. So aside from the initiation and then the promotion, again, from your initiation, it is irreversible onto your promotion, it is reversible. Let us see the last stage of the multi-stage carcinogenesis. So here is the final stage. It is a progression. It involves the conversion of benign neoplastic lesions into neoplastic cancer. In this stage, due to increase in DNA synthesis, cell proliferation in the preneoplastic lesions, additionally, genotoxic events may occur, resulting in additional DNA damage. So your genotoxic could add or could trigger even more the progression or the massive production or the rapid increase of the DNA synthesis. And of course, once you say genotoxic, it leads directly to DNA damaging, which includes chromosomal aberrations and translocations. Now, progression is an irreversible stage. So, again, come to think of it, your initiation is irreversible. However, your promotion is reversible. Well, the last stage is irreversible, just like your initiation. Now, again, since progression is a reversible stage in the neoplasm formation, either way, benign or malignant, it could occur. Okay? Chemicals that impact on the progression stage are usually genotoxic agents. And if genotoxic agents are already visible, they are the most known progressor agents. So they help, or these are usually clastogenic, which means it breaks the chromosomes. And your chromosomes belongs to, haman ninyo makitaan ang chromosomes. The X and Y. Where do you usually found it? Sa inyo going back to your biochemistry, where can you find chromosomes? Sa inyo nucleus. Tama ba? And your nucleus is the biggest organelle from your cell. So ideally, your cell is going to be really affected. And again, going back, since your progressor agents are clastogenic, which breaks chromosomes, these are also capable of causing chromosomal abnormalities. So the production of your chromosomes. Well, aside from that, we have hallmarks of progression. So these are the following. You have there the accumulation of the non-random chromosomal aberrations and also the karyotypic instabilities. Now, there are also considerations of the mechanisms of action of chemical carcinogens. The development of neoplasia requires two major events. These are the formation of an initiated and the mutated cell, and the other one is the selective proliferation of the mutated cell to form a neoplasm. Both of these events can be induced or act upon by chemical carcinogens. Now, if you're quite observant, chemicals that induce cancer have been broadly classified into one of two categories, which is the one that we mentioned earlier, the genotoxic or DNA, also known as DNA reactive. And on the other hand, we have here the non-genotoxic, which is also known as epigenetic carcinogens. This is based on their relative abilities to interact with the genomic DNA. So this is how they are interacting with the DNA genomic. So we have under your genotoxic, the mutagenesis. I know this is no longer new to you. So yeah, just a recall, damage by alkylating electrophiles and the DNA repair. Compared to your non-genotoxic, genotoxic is really quite specified since it is directly damaging compared to your non-genotoxic. It's still DNA damaging, but it is indirectly. So it goes on to this for particular interactions. So aside from that, to further see what could the genotoxic or the DNA reactive do, Gen- genotoxic carcinogens initiate tumors by producing DNA damage, as I mentioned in the beginning. Now, DNA reactive carcinogens can be further subdivided according to whether they are active in their parent form. So, let's say, for example, the direct acting carcinogens, these are agents that can probably directly bind to DNA without being metabolized. And we also have those that require metabolic activation. We have in there the indirect. Of course, if we have the direct acting, we also have the indirect acting carcinogens. These are compounds that require metabolism in order to react with the DNA. So again, going back to the features that I showed you earlier. So these are some of the things that we should consider. So in continuation, we have also the mutagenesis. It is a formation of mutation in DNA molecules. The reaction of a carcinogen with genomic DNA, either way, it is directly or indirectly, it may result in DNA adduct or bindings for or formation or DNA damage, directly DNA damage. And it could frequently produce then a possible mutation. Now, there are a variety of mutation that can occur in DNA, and several mechanisms of mutagenesis are known, such as mechanism is modification of DNA electrophilic carcinogens and the type of repair process used in response to the damage. So you have in here these mutations can occur by two categories, either the transitions or transversion. Under your transition, a substitution of one pyrimidine by the other, or let's say, for example, one purine is substituted by another purine. So, if you can still remember, what are the types of pyrimidine? What are the types of pyrimidine? And what are the types of purine?
Tong pyrimidine, ma'am, is katong cytosine, uracil, thymine. Then purine are guanine and adenine.
Okay, very good. Thank you for that. Great. Now, let me ask you rather, why is uracil not mostly included? Asa man di siya ga-attach on uracil?
Sa RNA siya.
Yes, exactly. It is mostly found to the RNAs compared to your thymine and your cytosine. It is for your DNA. Now going back, so it's just a review from your biochemistry. So if the case is substitution, let's say for example, your pyrimidine cytosine is substituted by thymine, it is still under transition. Or either way, if purine, let's say for example, your adenine is substituted by your guanine, it is still under transition. As long as there are substitution according to their category, let's say for example, purine, purine, pyrimidine, pyrimidine, that is transition. However, when transversion occurs, a purine could be replaced by a pyrimidine. So it is no longer it is no longer substitution, but it is already a replacement. So if transversion occurs, let's say for example, the adenine is being replaced by thymine, or the guanine is being replaced by cytosine. So we all know that they do not go along together. So they are being replaced. So let me show you an illustration. So there you go. So let's say, for example, for a better view. So you have here your purines, your adenine and your guanine. If either way of these two is being substituted, let's say for example, your adenine is being substituted by your guanine, these are still under the transition category. However, if your guanine is being replaced by a pyrimidine, such as cytosine, this is already a transversion. So transversions and transition mutation are results. So if there are replacement being held, it is because it is a result of misread DNA. Could also be a factor of frame shifting. Yes. Okay, and or broken DNA strand. So mostly the most common three factors or the results of having transversion, and transition could be the reason of misread DNA, frame shifting, or broken DNA strands. So that are the three most common reasons. So aside from that, we have here under the still the MOA of the chemical carcinogens, the damage by modification of DNA. So there you go. This is just a review from your pharmacology, the alkylating electrophiles, the hydroxylation of DNA bases, and the methylation of DNA. Now, as mentioned, most chemical carcinogens require metabolic activation to exert a carcinogenic effect. Kung i-compare nimo ang activation o katong mo direct lang siya o kanang effect, even though it is inactivated or it is not metabolized, the most percentage goes to the activation of the or the metabolic activation. It needs still to be metabolized. Now, the ultimate carcinogenic forms of these chemicals are frequently strong electrophile that can readily form covalent adducts with nucleophilic targets. Now, another common modification to DNA is the hydroxylation. So, by the way, there are a lot modification of DNA that could lead to damage. However, these are the most common. So another common modification to DNA is the hydroxylation, in which DNA bases were the source of oxidative DNA damage, which is typically formed from free radical reactions that occur endogenously in the cell or from exogenous sources. And after that, most of these two go along with the methylation of the DNA. So if there is a damage by modification of DNA, there is also the MOA of chemical carcinogens that it goes with the DNA repair. So during the DNA repair, the DNA region containing the adduct is removed and a new patch of DNA is being synthesized, while using, of course, the opposite intact strand as a possible template. To be effective in restoring a cell to normal, repair of DNA must occur prior to the cell division. So going to the katong mo balik mo sa replication, if you can still remember that one. Well, again, in order for a cell to become normal, it should be done prior to the cell division. Now, if repair is not complete prior to replication, the presence of the adducts can give rise to mispairing of bases and other genetic effects. Probably, it could result to rearrangements or translocations of DNA segments. Now, thus, let's say for example, a chemical that alters the repair process or the rate of cell division, it could definitely itself affect the frequency of the neoplastic transformation. So, as what you can see in here, these are the following DNA repair mechanism: the mismatch repair of single base mispairs, excision repair, and joining repair of non-homologous DNA. And before we move on to the next category of the chemical carcinogens. So we have here, your DNA repair and the damage due to modification of DNA. These are from your genotoxic agents. So if you have still time before the exam, kindly include in your readings the classes of genotoxic carcinogens. So I know you have gone through this, especially the alkylating agents, the polyaromatic hydrocarbons, and so on and so forth. Because if you have already gone through that, it is very sabotable naman. Hey. So just to let you have a review from your biochemistry. So it goes along with that. So let us move now to non-genotoxic. So of course, if we have the genotoxic, which is a DNA reactive, we have here the non-genotoxic or the epigenetic carcinogens. So of course, if the genotoxic has its own factors or mechanisms, also with your non-genotoxic. So your cytotoxicity, or also known as toxic in cell, of course, it's very sabotable. Chemicals under this one that function through this mechanism produce sustained cell death or apoptosis. This is often related to metabolism of the chemical that is being accompanied by persistent regenerative growth, which is resulting in potential for the acquisition of spontaneous DNA mutation, which allows, of course, the mutated cells to accumulate and proliferate. Aggressive production. So these processes then gives rise to preneoplastic focal lesions or those new growth na autonomous nga mga tissues that upon this, it can do further expansion and can lead to tumor formation. But then again, doesn't mean that tumor is already being formed. It is directly noted as cancer. So aside from that, we have there the alpha-2-globulin binding chemicals, in which it has the ability to bind onto globulin, which prevents the digestion of the alpha-2-globulin and could be in result of accumulation in lysosomes. So these are all part of your organelles. So it could dysfunction the lysosome under your organelles and could subsequently release of digestive enzymes and cell necrosis. Now, aside from that, it could possibly lead to increased cell proliferation in the P2 segment, which may be responsible for the tumor development, and it could lead to malignant transformation. So there are possible factors that could increase the development and the transformation of the possible tumor that is still in the benign state. It could develop into malignant state. So on the third basis, we have the receptor mediated. So in here, it requires the P450 inducers. Now, in this case, it increases cell proliferation, inhibition of apoptosis, inhibition of gap junctional communication, and the hypertrophy and possible development of preneoplastic focal lesions in the liver. So I guess we are all familiar with the CYP450, and we know how P450 inducers works. So aside from the P450 inducers, we also have the peroxisome proliferator. Now, this peroxisome proliferator, well, it activates actually this the receptor that is binding to this peroxisome proliferator. Now, the chemicals are capable under this category of increasing the number and volume of peroxisomes in the cytoplasm cells. Now, we have a lot of peroxisome proliferators that we should consider. We have their herbicides, chlorinated solvents, or also known as trichloroethylene, also the plasticizers, and the lipid-lowering fibrate drugs, or also known as the clofibrate. Now, all of these plays a central role in lipid metabolism. And actually, it acts as a transcription factor to modulate gene expression following ligand activation. So if there is a ligand, of course, there is a substrate. So effect arises through the heterodimerization of the PPAR and the RXR alpha, which results in binding to response elements and subsequent modulation of target gene transcription. Now, in this case, in this event, the induction of cell proliferation and suppression of apoptosis is being held. And if we have this cytotoxicity, the alpha-2 euglobulin binding chemicals and the receptor mediated, we also should consider the aryl hydrocarbon receptor, since these are considered as agonists. These are selective members of, I think that was, the polychlorinated. Yes, that was polychlorinated and the brominated biphenyl. These are the two popular compounds that have been linked to tumor development. So again, it is the polychlorinated and the brominated biphenyl. So these are a class of compounds that are being linked to tumor development and appears to function as hepatic tumor promoters. So it triggers, okay, since it is under the state of promotion, it is already irreversible. So once it is being triggered, so ideally it leads to possible greater DNA damage. Do you have any questions? Okay, so I'll consider that as a no. Okay, aside from that, from those four, we also consider hormonal mode of action. Well, hormonally active chemicals could be the biogenic amines, steroids, and peptide hormones that cause tissue-specific changes through interaction with a receptor. Well, when the mechanism of hormonal control are disrupted, some or other hormone shows persistently increased levels, which lead to the development of tumors. So ideally, it could increase the transition or the development of tumors from benign to malignant. Then aside from that, under your DNA methylation and carcinogenesis, under this process, the pattern of methylation is being observed in cells, which is being transformed by chemical oxidants, which contributes to an overall aberrant gene expression and promote the tumor process. So both of these two categories for the 7 and 8, since these are oxidative stress and oxidative damage, both of these could increase in reactive oxygen in the cell through either could be physiological modification or through chemical carcinogen exposure, which then contributes to the carcinogenesis process. Now, Actually, some of your endogenous sources, it could really be a reason of reactive oxygen species. So let's say, for example, we could consider the peroxisomes, inflammatory cell activation, or the P450 metabolism, or even the oxidative, what do you call that one? Phosphorylation. Yes, we could also consider that one. So both of these oxidative stress and oxidative damage, these are persistent in DNA damage that can result in either arrest or induction of transcription, induction of signal transduction, and could possibly also be a reason of genomic instability in which some of the events are potentially involved in carcinogenesis. So these are added notes for cytotoxicity and the rest of the 8 factors. So I'll just go over to this. So again, in this case, under your non-genotoxic, um, it has the capacity to proliferate, but it has a slow rate compared to your genotoxic, which has an aggressive proliferation. So mas paspas ang iyang pag-increase. So those are the things that you need to consider. Okay, so some of the carcinogenic factors could be associated with lifestyles. So these are the things that we need to check on to human or to patients. So some of these chemicals could be alcohol beverage, and the neoplasm that could be affected is your esophagus, liver, your oropharynx, and larynx. Aside from that, we have the aflatoxins. You can check onto the liver of the patient if how is it going, if the patient is being exposed to a such carcinogenic chemical, and also the battle chewing, and including the dietary intake, especially on fat, proteins, and calories. So we need to consider this kind of chemical carcinogenic based on the lifestyle. So probably, of course, tobacco smoking is very still a rampant consideration up until this very moment. Of course, these are the factors or the tissues that could be affected. No, mouth, pharynx, larynx, lung, esophagus, bladder. Aside from that, we also have occupational human carcinogenic. So for those people that are in the industry of construction, asbestos is still in the market and we are still using it. Arsenic is still being used. I hope not drastically, but cautiously, no? Even for those people that are in the manufacturing firms, in the laboratories, they are still also exposed with certain chemicals. So you need to be vigilant. So these are the possible neoplasms or origins that can be affected. So kindly take note of this, okay? This will be included to your exam. So let me just remind you, aside from that, we also still have this medical therapy and diagnosis, of course. The most common, chloramphenicol and the phenytoin, yes, it can associate to possible neoplasms. And these are the following. So in conclusion, a number of factors have been implicated in the induction of cancer in humans. And these are the things that you need to consider: the lifestyle, the infectious agents, the medical treatments, the environment, and then the environment exposure and the occupational exposure. So I think that would be all in relation to the non-organ directed toxicity. So this is going to be the main topic that is included to your exam next week. So do you have any question, clarification? None? Okay, so unfortunately, we will still be dealing with some of the um, case analysis for your laboratory. So kindly include this, especially on um, reviewing with the other antidotal measures and specific antidotes, since it this will also help out in the in analyzing the specific case analysis that I'll be giving you next week. So I think that would be all for today. If you don't have any question, I'll see you next week. Okay? That would be all. Thank you very much and have a great afternoon.
Bye, ma'am. Thank you.
Bye.
Bye, ma'am. Thank you.